Okay, enlarge the screen in the video. All right, so this going to be a nightly exercise, and it's specifically designed to help folks who might have some blanks. Didn't know how to do that problem on a midterm. Okay, so these are really basic building blocks. So the way we're going to do this is I'm just going to do it. I'm hoping that it takes me maybe 15 minutes. And obviously, if you're practicing these skills, you're going to stop the video, try the problem yourself, see if it matches up with what I do. Okay. So I don't know how much I'm going to talk about these. Hopefully not too much. Hopefully this is just drill. All right. So let's get going. So step one, the integral from 1 to 4 square root of x dx. And we'll see what it looks like. There's 1, there's 4. I'm going to look at area. And if I add up all of these strips of area, that's a strip of area. The height is the square root of x, and the width is dx, which is what that is saying. All right, so now we do it mechanically. So we hopefully have a sense of what we're looking for. Square root of x becomes x to the 1/2. Okay, so that's how you want to handle that. And so therefore we do x to the 1/2 plus 1 divided by 1/2 plus 1. That's 3/2. And when you divide by 3/2, it's the same as multiplying by 2/3. So this becomes 2/3 x to the 3/2 from 1 to 4. Now, how many of you are learning now that that means square root? I can cube 4, which gets me 64, and then take a square root. Or I can take the square root of 4, which is 2, and then cube it. You're getting the same answer. So it's always best to get small and then big as the numbers get more challenging. So this becomes the square root of 4 cubed times 2/3 minus the square root of 1 cubed times 2/3. Square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16 over 3. Minus 2/3. The answer is 14 over 3. And I captured it all on the video. All right. So now we are going to look at the mean value theorem for derivatives. You could always YouTube that for more practice. All right. What I've written is actually in graphing form. And I will write it in graphing form more clearly. Y equals x minus 0 cubed minus x minus 0 plus 0. It's another way of writing that. This graph goes through 0, 0, the origin. This is the tangent. So it's going down at 1 to 1. This term takes over, comes back up, goes back down. So that's the graph you're looking at. All right, now we're going to do the mean value theorem for derivatives, which is create a table to find the average rate of change. And we're going to look at x cubed minus x. What do we get when we put a minus 2 in? We get minus 8 minus a minus 2. Okay, if I don't make any mistakes, that's negative 6. So we would be over here somewhere at 2 comma negative 6. And then we want to put a 3 in. Is that right? Yes. 27 minus 3. Okay, 24. So that graph over here somewhere. All right, so we stay on the page. All right, what are we finding? That slope. Okay. All right. What did I do here? I went up 30 units, excuse me. I went up 30 units. Over here, I went up 5. That's a 30 to 5 slope. That's over 5, up 30. Rise over run. We'll call it 6 to 1. Okay? 6 to 1 rate of change. Where on the curve? Well, it's actually 2 places now. There's one over here somewhere going up at 6 to 1. This is not drawn to scale, and there's one here. where I have parallel tangents to this rate of change. These are the same. All right, so where are we now? We are finding the average rate of change, which is 6 to 1. We just found that. That's the average rate of change, 6 to 1, equaling instantaneous rate. We think we got two places. How do we find instantaneous rate? That's measured by slopes of tangents. We take the derivative. The derivative of x cubed is 3x squared. The derivative of minus x is minus 1. And now we solve. That becomes 7, 3x squared. We divide by 3, x squared. We bring the plus minus square root. Okay, so this is less than 9 divided by 3 is the square root of 3. So we are a little less than 1.73, plus or minus. Okay, is plus or minus 1.73 less than that bound, 3? Yes. Is it bigger than that one? I'll put a plus minus -2. Yeah. Okay, so those were the places, whoop, 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 right there and right there, that we are going up at the same rate as the average rate. All right, next problem. I'll erase that later. Okay, this one over here, we're going to do 5 quick limits. All right, you're supposed to remember you're pausing the video. I'm just continuing on. So I see the same exponent. Same exponent as I go to infinity. Infinity means that these are the terms. Those are the terms that have the most influence over the numerics. When I put a million in, 4 times a million is dwarfed by a million times 3. So this goes to 2/3. That's pure recognition. This is going up faster than that at a 2 to 3 ratio. When this is smaller, when that is smaller than this is going up so much faster than that. Okay, so I can get rid of this, right? This is going up so much faster than that, then it goes to 0. Those are rules you just want to know. Now, if I go to 0, well, I'm not looking at these terms anymore, right? These are the ones that matter. So if I go to 0, this thing goes to, right now, -5/9. It's just, and then if I get rid of this term, and I go to 0. So what is the limit? This is the last one we'll look at. What's the limit as x goes to 0 of 5 over 4x? It might be good to look at this graphically. Different perspective. Here's 5. That's a height of 5. 4x cuts through, right? What do I have on the left side? A nominal negative y value. Something like, it's still 5-ish, right? It's 5-ish. 5 divided by something over here is that y value, maybe minus 0.01. I can keep throwing zeros in there. The more zeros I throw in, the more it heads to negative infinity. Whereas if I divide by that, 5 divided by positive 1, it's going to positive infinity. Well, we're not going to the same y values. The limit doesn't exist. Okay? I say okay a lot. I'm going to stop saying it. Okay? Product rule. Y prime. We know the drill, perfunctory. I'm just going to use words of the day throughout the class from now on. Derivative of the first, 2e to the 2x times the second, tan of 3x. Space-wise, I'm going to do plus underneath. I think what I'll do from now on is I usually do the derivative of that times that, but I think I'll keep the same order. This time I'm going to leave that one alone, but I'm going to multiply it times the derivative of this one. Derivative of tan is the secant squared with respect to where I am on the graph, and that's determined by 3 times x. So if I said x was 5, I'm not looking at the secant squared of 5. I'm looking actually at secant squared of 15 on that graph. You probably haven't graphed secant x. All right, times what? The derivative of what's inside. We're going to do that from now on everything. That's the product rule. Now we're going to do the quotient rule with the same numbers or the same functions. So we're going to do low tan of 3x. Well, I got to start over here left because I'm going to run into that probably. So y prime is equal to low tan of 3x times the derivative of high, which is 2e to the 2x, minus high e to the 2x times the derivative of low. We've already done it. Secant squared 3x times 3. All over low, which is tan squared 3x. There's your quotient rule. We don't want to blank on the next test. We want to learn that. Little u substitution. Here's your u. I should give you a little more time to see the problem. Pause the video. Maybe you did. All right. If you did, use this as u. I hope you're already anticipating what that number should be. Huh? Yeah, I'm hoping you're saying, oh, I got a du 21x squared coming my way. I got a du 21x squared coming my way. You know what? I think I can take 10 over 21 out of this critter. And I think the x squareds cancel. I think this boils down to a u to the 5 du problem. I know what that is. That's u to the 6 over 6 plus c. Times what? I mean, you're going to do the integration before you do the multiplication, 10 over 21. I think we're ready to answer this. I think I've got 10 parentheses. I go back to u, which is, I'm sorry, I should have said minus 4 here. Right, that is your u. So backtrack. Keep that in mind. Have some confidence in what you do. I'll catch my errors if I'm talking too fast and trying to just put something up there so that my whole life isn't looking at myself. U, 7x to the third minus 4 to the 6 over 126 plus c. All right, hopefully getting some, did I say okay again? Let me catch myself. I do that too. Yeah, stop that too. I might do that. All right, so this is all about finding y equals. This is a find y equals. This is not a equation of a line tangent. This is, let's solve for y. All right, so there should be some directions here. Solve for y. Okay, so what did this thing come from? I hope you see that it came from x to the 4th. Let's change this. Let's make it a 6 because I don't feel like playing with fractions right now. Where did that come from? I hope you said 3x squared plus c. Now when you plug a 0 in, we want a 9. I don't think we're going to make a math error on this one. Done. First order differential equation. So instead of saying okay now, I'm probably going to nod. All right, last one. Your algebra skills, you're stuck. So what do? You rewrite it in a way that hopefully makes sense to you. We can take the 3 out. We can do a 1 over x to the 5/4 dx. We get rid of what's in the way here. That's history. History in the making, right there. History. The final, no. We've been talking about this in class quite a bit. Not sure what to do with it. Rewrite it. 3 times the integral of x to the minus 5/4 dx. I think we're ready. 3 times x to the minus 5/4 plus 1. I think we want to write 1 as 4 over 4. Right now I have negative 1/4. So that's what I'm dividing by, negative 1/4 plus c. You can see this, yes. How many times does negative 1/4 go into 3? Minus 12 times, because you're really going to multiply by negative 4 over 1, the reciprocal. All right, so this should be minus 12. this should be x to the minus 1/4. And you should be able to rewrite that back to this kind of notation. So this is the same thing as minus 12 over x to the 1/4. And what's another name for x to the 1/4? The 4th root of x. That's our answer. I'm hoping through repetition we might close some gaps from your algebra 2. All right, that maybe we can start to see how to rename these things and put that in your pocket as a skill. That's it. All right, those are the problems that we practiced for everyone. Folks can do it or not do it, but if you're leaving blanks on your midterm, I strongly suggest you take every night the chance to go through this and at your own pace and check your answers with mine, like I just did them, and I think you'll build your skill level. So that's tonight. I'm going to put this on Canvas right now. I'm going to do another one tomorrow night. Ciao, ciao. See you in a couple hours.